For question number 27, part A, we have to evaluate the definite integral. So, our definite integral, let's consider this as I, which is has to be rated from -2 to 2 under root 2 minus x upon 2 plus x into dx. And let's rationalize it first. So, rationalizing means multiplying the numerator and denominator with the conjugate of the denominator. So, its conjugate is 2 minus x, which gives us -2 to 2. This is under root 2 minus x the whole square upon this is now a square minus b square. And finally, our integral is I is equal to -2 to 2. This is under root 2 minus x the whole square upon under root. This is 2 square minus x square. So this gets cancelled, and this is -2 to 2, 2 minus x the whole square upon under root 2 square minus x square into dx. So this has all these has the differential element dx. Okay, so this is actually not square. Okay, now let me separate these terms. So -2 to 2. So this is 2 upon under root of 2 square minus x square minus into dx, integration of -2 to 2, which can be written as x on under root of 2 square minus x square into dx. Okay, 2 can be taken out for this. So this is I is equal to 2 is out, -2 to 2. And this is integration of root of 2 square minus x square into dx. Minus this is -2 to 2 x upon under root of 2 square minus x square into dx. Okay, now let's consider this function. Let's consider this function as I1 and the other one as I2. So if I consider I1, so this is I1 is integration of dx upon under root. This is 2 square minus x square into dx. Now this function, our function is f of x, that is 1 upon root of 2 square minus x square. Okay, now f of negative x is equal to 1 upon under root of 2 square. So this is 2 square and negative x square, which still gives me f of negative x is equal to 1 upon 2 square minus x square. So it still gives me f of x. So that means this function is even. And when the function is even, the integration of 0 raised power a or 0 raised power uh, that is when the function is even. So when the function is even, so function the integral 0 to a f of x in the integral of f of x 0 to a, it can be written as 2 into integration of this can be written as 2 into integration of 0 to a 0 to a f of x into dx, and this property is negative a to a. So if the definite integral negative a to a f of x is even, which indeed this is, so this can be written as 2 into 0 to a f of x into dx. So that means I can write this function that is negative 2 to 2, because this function is even, so I can write it as 2 into integration of 0 to a. So this is negative 2 to 2, and I can write this as 0 to a f of x, which is dx into root of 2 square minus x square into dx. Okay, so this function now becomes I1 is equal to 2 into, and this is the formula. We know that the formula of for the differentiation of, sorry, the integration of, we know that the integration of under root a square minus x square is equal to sine inverse x by a. So using this formula on this, we get, so this is sine inverse x by a, which is Okay, so we have got I1. So this is sine inverse x by a. And let's get, so this value becomes 2 into, so let's replace the value of I1, which is 2 into sine inverse x by 2. And it has to be vetted for the limits -2 to 2. So -2 to 2 are the limits. Okay, and I2. So let's check our function I2. This is I2. And if I check this function, this is odd. So f of x is x upon root of 2 square minus x square. And if I put it this way, if I evaluate this for negative x, this is negative x upon root of 2 square minus x square, which is my negative of x. So that means this f of x is odd. And when f of x is odd, negative a to a into f of x should be equal to 0. This is the property. So this is I2. So I2 becomes equal to 0. So this is negative 0. So we are only left with our integral is, we have only, so 2 into 2 is 4. So this is 4 sine inverse x by 2. And now the limits are not to negative a to a. These are actually 0 to 2. This is actually now 0 to 2. So this is 0 to 2. We have used the property here. So I is equal to 4. This is sine inverse 2 by 2 minus sine inverse 0 by 2. So I is equal to 4. This is 1. So sine inverse 1, angle for which the value of sine is 1 is pi by 2. This is sine 0. And the angle for which the sine 0 is 0. Okay, so now this is 4 into pi by 2, which becomes 2 pi. So 2 pi is the answer for this. And we have solved this using the properties of the definite integral. So let's move on to part B of the same question, that is question number 27, part B.